All right, looking to set up this volume problem. This came from one of the Lumen exercises. We're trying to set up volume under the surface. Well, the question that I got says the surface z equals xy squared. That's not the hard part. The area is bounded by some curves down here. So this one says area bounded by x equals y squared and x plus 2y equals 8. Now, these can both be put into x equals form pretty quickly, and that's probably what we want to think about on this is x equals form on that. We want both of our bounds to be, neither of them's a constant. We want both of the bounds to be functions here, one way or the other, and these can be put in x equals form and be functions of y. So I can rewrite those two things. Well, this one's already x equals, and the other one's x equals negative 2y plus 8. They're both. Written as functions of y. So if I'm doing a setup right here for a double integral, if I can have functions of y, then I'll put the y as the outside one, and x will be between these things somehow. So it'll be in this order, and x goes from one of these things to the other, but I don't know which one's left, right from looking at it. These are going to be sides, but I'd have to think about what the picture is here to know which one's left and which one's right that I'm going to and from. And I got to think about what y is going to go to and from as the numbers on the outside one. So I really need to think about the picture of these things now. X equals y squared is your sideways parabola where x is always positive, going through the origin, and x equals negative 2y plus 8. That, let's see, that goes through when y is 0, x is 8. And when y is 4, x is 0. So I got a line going this way. That's slope minus 1/2, but we're looking at this in x equals form, so looks a little weird, but that's what the line looks like. So they're going to intersect somewhere here and then somewhere out off the picture, and we're looking at region going this way. So left and right are more obvious on the picture. The parabola is the left side and the line is the right side. So I can tell I'm going from y squared to negative 2y plus 8. I'll put those in, and then I got to think about what values of y I need to cover on this. I need the actual y value where they intersect. The two y values where they intersect. Those are the numbers that I need for here. So I got to find points of intersection. That's part of the process here. I need to know where y squared intersects with negative 2y plus 8. So we got a simple equation once you get it organized. That's what I need to know. And y plus 4 and y minus 2 are the factors there. So y is negative 4 and y is 2. This would be where y is 2 on the picture, and this is down at negative 4. And that's where I need to start and stop my integration to cover that region. So negative 4 to 2 takes a little work off from that sketch to get all that set up. Now, actual antiderivatives of those things are not hard. So that's set up okay. But in any case, whatever you're starting with up here for your equations, you want them both in x equals form or both in y equals form, and then you need to get that drawing well done to see if it's left and right side, or if they're in y equals form, it's going to be top and bottom. That's really what you got to work with. And you got to find intersection points typically on these things. Even if one of these was a constant, you got to see where the curve runs into the constant, so you still have to find where the two things are equal. That's your start and stop points. That's the typical process to set up on this. Now I'm ready to do antiderivative with respect to x on that, which is easy enough. So looks like some polynomials we're going to end up with from there. But that's the setup part, and that's one more example of the thought process. Hope that helps.